Hello everyone, welcome to Math is Fun. Our lesson for today is all about properties of logarithms. What is a logarithm? Logarithm is the inverse function to exponentiation. This means that the logarithm of a number x to the base b is the exponent to which b must be raised to produce x. Also, a log can undo an exponential. Likewise, can use to solve exponential equations. Example of exponentiation is 10 raised to the exponent of 2 is equal to 100. In the base 10 system, 10 must be multiplied by 10 to produce 100. To write this in an inverse function which is logarithm, we do like this. Log base 10 of 100 is equal to 2. Logarithms have different applications in our real-life situations. A logarithmic scale is used as a tool to deal with a large range of values. The common application of the logarithmic function is to find the compound interest, exponential growth and decay, to find the pH level of substance, to know the magnitude of an earthquake, and also to compute the number of visits per day on Google search homepage. Okay, let's study now the properties of logarithms. We can use this to evaluate logarithms. The first property of logarithm is the logarithm of 1 to any base is always 0. This is because any number raised to 0 is equal to 1. For example, log base 10 of 1 is equal to 0. If we're going to write this into an exponential equation, it goes like this. 10 raised to the exponent of 0 is equal to 1. Next property is the logarithm of a number to the same base is 1. For example, log base 5 of 5 is equal to 1. If we're going to change this into an exponential equation, it goes like this. Log 5 raised to the exponent of 1 is equal to 5. Another property is log base b of b raised to the exponent of x is equal to x. So here, b is cancelled. So the answer is equal to x. For example, log base 5 of 5 raised to the exponent of 4, the answer is equal to 4. So the remaining is just the exponent. Another one, log base 7 of 7 raised to the exponent of 3 is equal to 3. Another property is the product rule. Log A plus log B is equal to log A times B. For example, log base 10 of 4 plus log base 10 of 7. This is equal to log base 10 of 4 times 7. And the final answer is log base 10 of 28. Another example, log base B of 9 plus log base B of 8. This is equal to log base B of 9 times 8, which is equal to log base B of 72. Property is the quotient rule. Log A minus log B is equal to log A divided by log B. For example, log base 10 of 8 minus log base 10 of 4. This is equal to log base 10 of 8 divided by log base 10 of 4, which is the final answer is log base 10 of 2. Another example of the quotient rule. Log 10x fourth minus log 2x, this is equal to log 10x fourth divided by log 2x. So 10 divided by 2 is equal to 5, x fourth divided by x is equal to x cubed. So our final answer is log 5x cubed. Another property is log a raised to the exponent of n. This is equal to n log a. So here in this property, we put the exponent n in front of log. For example, log base 10 of 8 raised to the exponent of 2. This is equal to 2 log 10 of 8. Another example, log x to the exponent of 6. This is equal to 6 log x. Since we know already some of the properties of logarithm, let's evaluate the logarithm functions. Our first example, log base 3 of 81. So in this example, we are going to evaluate this logarithmic function. So what is your answer? So we're going to think how many times we're going to multiply 3 by itself to get the answer of 81. So this is 3 times 3 times 3 times 3 is equal to 81. If we're going to write this in an exponential form, it goes like this. 3 raised to the exponent of 4 is equal to 81. Therefore, if we're going to evaluate log base 3 of 81, the answer is equal to 4. Another example, log base 7 of 49. So how many times we multiply 7 to get the answer of 49? Alright, 7 times 7 is equal to 49. Or 7 raised to the exponent of 2 is equal to 49. Therefore, if we're going to evaluate log base 7 of 49, the answer is equal to 2. Another example, evaluate log base 5 of 625. How many times we multiply 5 by itself to get the answer of 625? Alright, this is 5 times 5 times 5 times 5, which is equal to 625, or 5 raised to the power of 4. So if we're going to evaluate log base 5 of 625, the answer is equal to 4. How about this example? Log base 625 of 5. So look at this, 625 is the base now. Therefore, our answer is 1/4. Another one, log base 5 of 1 over 625. So here, our answer is a negative number. So it is -4. How about this example? Log base 625 of 1/5. So this is also -1/4. Another example, log of 1000. So in this example, we're going to count how many zeros are there in 1000. And of course, there are 3 zeros. So log of 1000 is 3. Log of 10, the answer is, of course, 1. Log of 100, okay, the answer is equal to 2. Log of 1 million, alright, how many zeros are there in 1 million? Alright, it is 6. So log of 1 million is equal to 6. Alright, next example, log base 2 of square root of 32. So in this example, we're going to rename square root of 32 into an exponent form. So here, 32 has an exponent of 1, and of course, the index is equal to 2. So we have log base 2 of 32 raised to the power of 1/2. Then we're going to apply the power rule. So we put 1/2 in front of log. So we have here 1/2 log base 2 of 32. Then we're going to solve log base 2 of 32. So we have here log base 2 of 32. We're going to think how many times we're going to multiply 2 by itself to get the answer of 32. So we have 2 times 2 times 2 times 2 times 2. So this is equal to 2 to the 5th is equal to 32. So this means that log base 2 of 32 is equal to 5. Then, we multiply it by 1/2. What is our final answer? Alright, the final answer is 5/2. Another example, log base 8 of cube root of 512. To evaluate this logarithmic function, we're going to rewrite the cube root of 512. So we have log base 8 of 512 raised to the exponent of 1/3. Then, using the power rule, we put 1/3 in front of log 8. So we have 1/3 log base 8 of 512. Then we're going to evaluate log base 8 of 512. So in this example, we're going to think how many times we multiply 8 by itself to get the answer of 512. Alright, so we have 8 times 8, which is equal to 64 times 8, which is equal to 512. Or 8 raised to the exponent of 3 is equal to 512. Therefore, log base 8 of 512 is equal to 3. Then, we multiply it by 1/3. And what is our final answer? Alright, the final answer is 1. That's all for today. I hope that you understand our lesson. Thank you for watching.